right, so let's take a look at the homework. So, so you can see number 1 and number 2 right here. So take a look at those. Number one is actually easier, but it's often confusing to students. This is a quadratic where the constant term is missing. So it's just, cosine squared plus cosine. There's no constant. So to solve a quadratic like that, you just need to factor out the cosine. So there's this common cosine that can be factored out. Once it's factored, you now have, two things that are multiplying each other that to equal 0. So either this equals 0 or that equals 0. And then you have these two small little equations that you can solve. So I got two answers here, pi over 2 and 3 pi over 2. There are two angles that have a cosine value of 0. And then over here, I also had two angles. So there are two angles, one in quadrant 2 and one in quadrant 3 that have a cosine value of -1/2. So that one had 4 solutions. Number 2 is a little bit more straightforward. It looks like the ones we did in the note. So factor it into two sets of parentheses. Split those into two little mini equations, and you're going to get the inverse sine of -1/2 and the inverse sine of 1. And then these are the two angles that solve this equation, and this is the one angle that's going to solve that equation. Number 3 is actually already factored for you. Okay, this is already two things being multiplied together. Just set each one of them equal to 0 and then solve them individually. Now the secant one, remember, secant is the reciprocal of cosine. So if you want to solve a secant problem, you flip it, you rewrite it as its reciprocal. You also rewrite the number as its reciprocal. Okay, it looks like we didn't do anything here, but we did. It's just the reciprocal of 1 is still 1. So it looks like we didn't. Okay, but then this I can solve. The inverse cosine of +1 is 0, just 0. Okay, pi has a cosine value of -1, not +1. Number 4, I had different variables. So I had to take sine squared, rewrite it as 1 minus cosine squared. Then everything's in terms of cosines. I can combine these two. I've got a negative cosine squared and another negative cosine squared, so I have -2 cosine squared. I moved everything to the right. Why? Because I need the cosine squared to be positive to be able to factor this. Again, this is one of those that you just factor out a greatest common factor and then set each of these equal to 0 individually and then solve individually. Okay? Again, when I keep solving this, and I didn't show every single step, but I'm going to move that 1 over, divide by 2, there's going to be a -1/2 over here. And that's why I'm picking the angles that are in quadrants 2 and 3, because that's where cosine is negative. Numbers 5 and 6. Number 5, again, I rewrote sine squared as 1 minus cosine squared, so I could have common variables. I also distributed that 6 into the parentheses to kind of open things up. And then I moved everything to one side, and I factored. Now, this factor doesn't give us a solution. There is no angle that has a cosine value of -5. So that one's not going to give us a solution. Number 6, I had a double angle, cosine of 2 theta, and then I had sine squared. Well, there's a formula that says that cosine of 2 theta, the double angle formula, can be set equal to 1 minus 2 sine squared. So if I use that formula to get all my variables the same, now I can solve this. I can combine like terms. I can divide by 4. I can then take the square root of both sides. I've got a sine squared, I've got a 3/4. So I'm going to take the square root of both sides. That's going to give me positive and negative radical 3/2, which is on our chart. So I'm going to write down all 4 angles that have a sine value of radical 3/2. 7, I did a little trick here. And If you tried and experimented, you may have come across this, but if not, okay, it's okay. I've got a cosine and a sine. I can't change cosine into sine or sine into cosine. That doesn't help me. Okay, what I did was I divided both sides by cosine just to rewrite it. I didn't get anything to cancel technically. I just rewrote this as a, well, sine over cosine is tangent. I rewrote it as a tangent problem. Okay, so by dividing both sides by cosine, I created this little tangent problem. Now I only have tangent. This is positive 1, and pi over 4 and 5 pi over 4 are the two angles that have a tangent value of positive 1. I kind of did a similar trick for number 8. I rewrote tangent as sine over cosine. I then cross-multiplied to get that cosine out of the denominator, which gave me this. So I've got sine equals 2 sine cosine. Well, I then moved the sine. I got everything on the same side. I moved the sine over. And you're looking at this right here and thinking, well, you've got different variables. You've got a sine and a cosine and then a sine again. But watch. These are two terms. I've got 2 sine cosine and I've got just plain sine. Both of these two terms have a common factor of sine, so I can factor it out. Once I factor it out, my two little mini equations that would be my next step, this equation only involves sine, this equation only involves cosine. So even though I still have the word sine and cosine, two different variables, when I split them, the individual little mini equations only have sine for this one and cosine for this one, so I can solve these individually and figure out what angles have these values. Okay? A lot of the problems, especially on this page, if you struggle, if you weren't quite sure what to do, that's okay. You're going to get a second day to practice to kind of to learn some of these little tricks. 9 is kind of straightforward. I just rewrote the double angle using the 2 cosine squared minus 1 formula, and then that was a quadratic, and I solved that one. So follow my steps. You should be able to see what I did there. Number 10, this factors. It factors into 2 sine minus 3 and sine minus 1, but this one doesn't give us any solutions. Okay, this will give you theta equals the inverse sine of 3 halves. 3 halves is bigger than 1. There is no angle that has a sine value of 3 halves. So this is the only solution that you get from this equation. Number 11, I had a cosine over here. I had a sine squared over here. I rewrote sine squared as 1 minus cosine squared. Now I have nothing but cosines. I can factor, and I can solve these two mini equations, though the one on the left doesn't give me a solution. I only get the solutions on the right. And then 12, last one. So I rewrote tangent squared as secant squared minus 1. So now I have everything in terms of secant. I was also not a fan of this fraction right here, 3 halves. So I rewrote that. I multiplied everything by 2. So I cleared that fraction by multiplying everything by 2. So now I have 2 secant squared. I now have a minus 2 instead of a minus 1. And now I have 3 secant theta. I moved everything to one side. This is an equals. That did not scan very well. That's equals 0. I've got everything on one side. I then factored, and then I solved these two problems. Again, to solve secant, you're going to rewrite this as a cosine. So for this one, you're going to get secant equals negative 1/2, and then you're going to have to rewrite that as a cosine problem, which is going to end up with theta equals the inverse cosine of, well, when you take negative 1/2 and flip it, you're going to get negative 2. There is no angle that has a cosine value of negative 2. So that one doesn't give you a solution, but this one does. Because when you move that minus 2 to the other side and get a 2, or 2 over 1, eventually you're going to flip that into 1 over 2. It's going to be the inverse cosine of positive 1 over 2, and that does have solutions. It has these two angles right here. So those are the solutions to day 1.